Okay, welcome from the break. We continue looking at solving problems with the Newton's equations of motion. This is example number 5, and it reads: a train accelerates uniformly at the rate of 4 meters per second square. If the initial velocity of the train is 40 meters per second, calculate its velocity traveling a distance of 250 meters. Great. First, let's list the parameters or the data in this example. There is an acceleration A, which is 4 meters per second square. Also, there is an initial velocity U of 40 meters per second. Then a distance with a symbol S of 250 meters. You are supposed to find the velocity, and this velocity in question is the final velocity, since the initial is also stated. Now, as usual, use this data and compare which of these equations here will work perfectly for us. We are looking for V. Equation 1 has a V. Equation 3 has a V. Now, if you consider equation 1, you will need U. Of course, U is given. You as well need A, and A is given. T is required, but unfortunately, T is not in the data, and so we cannot find V without the T. Let's consider equation 3. Looking for V, you will need U, which is provided in the question. A, also given. Then S, the distance, is also given. So that simply tells that in order to solve that question, we need to use V square equals U square plus 2AS. Let's then substitute into the equation. And that will be V square equal the U is given as 40 square plus 2 times A, which is 4, times the distance S, that is 250 meters. So friends, from our calculator, let's point the whole of this, that is 40 square plus 2 times 4 times 250, and that will be 3,600. So you say V square equals 3,600. In order to calculate for the V, you take the square root of both sides, and that will be V when the square cancel the square root. Then the square root of 3,600 is equal to 60. So V is equal to 60 meters per second. So that is the answer for example number 5. Example number 6 reads: a particle moved from rest through a distance of 25 meters in 10 seconds. Calculate the magnitude of its acceleration. Okay, so the data in this question is, so far as it starts from rest, the U is 0 meter per second. Travel the distance S of 25 meters in a time T of 10 seconds. We are required to calculate the magnitude of the acceleration A. That is what we don't know. Now, looking at the equation critically, but this time, I believe you will choose it yourself. And I can see that it is equation number 2 that is applicable in this question. So we will use S equals ut plus half at squared. Then we find the A. Let's substitute into this equation. For the S, it is 25 meters u0 time 10 seconds plus half of A. A is unknown, but T is known as 10 and the square. Okay, so this will still give you 25 equals 0 times 10 is 0. So that goes off. But you are left with half of A times 10 square. And 10 square is 100. So you're going to have it as half of A times 100. So 25 equals half of 100 is 50. Multiplied by A becomes 50A. In order to find for A, divide both sides by 50. And when the 50 cancels the other 50, you are left with A. 25 over 50 is actually equal to 1 over 2, which translates into decimals as 0.5 meters per second square. So this is the acceleration of the question. Thank you. Example number 7. A car traveling at 20 meters per second undergoes a uniform retardation of 4 meters per second square when the brakes are applied. Calculate the A. Time taken to come to rest. B. Distance traveled when the brakes were applied till the car stops. So example 7 is also another dimension of question that we need to know. This time we have a retardation, otherwise also called a deceleration, which only translates to mean that the acceleration is negative. And so, looking at the parameters of the question, a car traveling at, so that is the initial velocity the car was traveling with. So U is equal to 20 meters per second at a uniform retardation. So you can say acceleration, but it is negative to signify a deceleration when the brakes were applied. We have to calculate the time the car came to rest. But because the car came to rest, it is taking that the final velocity is 0 meter per second. Okay, so this is all that we know. With this, equation 1 becomes applicable. Looking at the data given, we're going to use V equals U plus 80, and we'll find the time. So A says time. And let's substitute. V is 0, U 20, plus A negative 4 times the T, which is unknown. This will translate into 0 equals 20 minus 4T. A little grouping of lightens. Let the negative 40 cross the equal sign to become positive 40 equals 20. Then divide both sides by 4 to find T. And T is equal to 20 over 4, which is 5, and the unit is second. So A, which said time taken to come to rest, and that time is 5 seconds. Now for the B aspect, we have to calculate the distance traveled before, when the brakes were applied, before the car fully stopped. So that full distance traveled. Looking at the parameters, we have u, a, v, and t. Distance, you could use equation 2 or equation 3. Any of them should work. There is even this equation, which during the proving or derivation of the Newton's equation, we made mention of. That is S equals V plus U all over 2 times T. This is also applicable in this sense. Okay, so for the B, let's use equation number 3. That is V square equal U square plus 2AS to find the distance traveled. That will mean 0 square for V, U is 20 and squared, plus 2 times A, which is negative 4, times S, which is unknown. This will be 0 equals 20 square is a 400 minus 2 times negative 4 is negative 8S. Let that cross the equal sign to become positive 8S equal to 400. Divide both sides by 8 to find S. Then from our calculator, 400 divided by 8 is actually 50. So the answer is 50 meters. That is if you use the equation number 3. You could as well use the other alternatives like what I just wrote here. That is the S equals V plus U all over 2 times T. So S is what we are looking for. The value of the V is 0 plus the value of the U is 20 all over 2 times the time we just found as 5. S is equal to the addition of 0 and 20 is 20 divided by 2 will be 10 by 5. S is equal to 10 by 5. That is also equal to 50 meters. So this also works perfectly. And as I said, equation 2 will also work. And I want you to try that on your own. Example number 8. A train traveling with a velocity of 16 meters per second is brought to a uniform rest when the brakes were applied in 20 seconds. Calculate the A. Deceleration of the train that brought it to rest. B. Distance the train traveled when the brakes were applied till it was brought to full stop. From this data, you have an initial velocity of 60 meters per second. And this train was brought to rest, which means the final velocity is rather 0 meters per second within a time t of 20 seconds. Okay, we are supposed to look for A, the deceleration. So A, are looking for the acceleration, but this time it's going to be negative. So looking at the equations very well, having U, V, and T, and looking for A, equation 1 will fit and work perfectly. Let's now substitute. The value of V is 0, whereas U is 60, plus A is unknown, but T is 20. Great. So 0 equals 60 plus 20A. when you expand this. Let's group like terms here. So the positive 20a will cross the equal sign to now be negative 20a, and it's equal to 60. In order to find a, we divide both sides by negative 20, and after cancellation, a will be 60 divided by negative 20 is a negative 3 meters per second square. So that is the answer. And so long as the answer is in negative, it fits the A that is a deceleration of the train. For B, looking for distance, and S is what you're looking for. With equation 2, knowing U, T, and A, we can use that. Equation 3 will also help in finding the distance. And equation 4 here will also help in finding the distance. So any of these is correct. Let me use equation 2 to solve for the distance. So S is equal to U, which is 60 times the T, 20, plus half of A. And A is negative 3 times the T square. That is 20 square. S translates to be equal to 60 times 20. That is 1,200. You can confirm that on the calculator. That is it. Plus half of negative 3 times 20 squared will be negative 600. S is actually equal to 1,200 minus 600, which will give the answer as 600 meters. So I want you to use the other alternatives to get the similar answer. Example number 9. A train running along a straight track at 30 meters per second is slowed uniformly to a stop in 44 seconds. Find the acceleration and the stopping distance. So the example 9, 8, and 7 have all been deceleration questions, since the body stopped at its final velocity. The data in the question, U, initial velocity, is 30 meters per second. Because it was slow to a uniform stop, the V is 0 meters per second, a time of 44 seconds. We are supposed to look for the acceleration and the distance. That's the full distance it covered before stopping. How do we solve for acceleration A? If you look at the parameters and the data given, U, V, and T, equation 1 fits in this regard as well. So using V equals U plus AT, don't forget we are looking for acceleration, and in this case it has to be negative. Okay, so let's substitute. V is 0, U 30, plus A times the time 44. 0 equals 30 plus 44A. Grouping like terms, the 44A will cross the equal sign to be negative 44A equal to 30. Then you divide both sides by negative 44 in order to find A. So in this regard, we can then say 30 divided by negative 44 is a negative 15 over 22. In decimals, it will be negative 0.68. Okay. And that's the acceleration, which is in fact a deceleration. The v aspect, the stopping distance. So far we have used equation 2, 3, and the 4 as well to solve for the distance. For this time, let me use the last equation again. So S equals V plus U all over 2 times T to find the distance. So V in this case is 0 plus the U, which is 30 over 2 times the time, 44. So S equals 0 plus 30 over 2 is 15. Then 15 times 44 is 660. Therefore, the stopping distance is 660 meters. You could also solve the same question using the other alternative, like let's pick, say, equation 3. S will be made the subject if you want to use that. So that will be V square equals U square plus 2AS. Great. If you substitute or make S a subject, any of them is correct. V is 0, U is 30, and squared plus 2 times A which is a negative 0.68 times the S, which is unknown. This will give us 0 equals, let's punch the whole of this on the calculator. Okay, so this is 900, then 2 times negative 0.68 is negative 1.36 S. Let that cross the equal sign and to be positive 1.36 S equal to 900. You find for the distance S, you divide both sides by 1.36, and S will be 661 meters. Though this has gone beyond the other one here, partly because of the decimals we shorten here, 0.68. There were other ones like 1 and other. If you have added it more, 4 or 3 decimal places, the answer will have been the same. All the same, they are closer. Thank you. Let's solve our last question. Example number 10. A vehicle with an initial velocity of 6 meters per second accelerates uniformly until its velocity changes by 18 meters per second after covering a distance of 90 meters. A. Determine the time taken to cover the distance. B. What is the acceleration of the motion? The data in the question is, we have initial velocity u to be equal to 6 meters per second. Then there was a final velocity. But take notice of what happened here. It says that the velocity changes by, this is the word I want you to take notice of, changes by 18. When we say change by, then that is the additional value to be added to the original. Example, I am, say, 30 years. If my age changes by 1, I am 31 years now. So changes by simply means that you add that new value to the original value. So in this our case, the initial value was 6 and it changed by 18. That will make the final velocity 24 meters per second. Notice something here. There is a difference like changes to. Changes to, then the value is maintained. Changes by, you add up. I trust you have understood this. Then there was a distance s given as 90 meters. We are supposed to look for the time taken, having s, v, and u. So let's look at the question. If we decide to use equation 3, our problem will be the a. If we decide also to use equation 2, there is u, there is t, but we don't have t here. So this is a dicey question. We're looking for the time. But look at the equation 4. V plus u over 2 times t. This works perfectly. Since we know s, you know v, you know u, then we are looking for t. So that is the way out. Or better still, there is an alternative, but let's start with this one first. So using s equals v plus u over 2 times t. So it was this equation that gave birth to the equation 2 and equation 3. I still trust you remember doing the derivation. So s in this case is 90 to bracket v 24 plus u 6 all over 2 times the t. So 90 still holds. 24 plus 6 is 30. 30 divided by 2 is 15. And that multiplies t to be 15t. Let's divide both sides by 15 in order to find t. So t will be 90 divided by 15. And the answer is 6. So we have the time taken to be 6 seconds. So that is one of the brilliant ways of solving this question. But as I said, we could also have an alternative. We could have first found the a, the acceleration, that is the b, using equation number 3. Since we knew v, u, and s, we could just find a. After getting a, you substitute a into equation 1 to find the t. That is another alternative. I will leave that for you to explore. So solving for the b aspect, the acceleration, having had u, v, s, and t, we could go ahead to use v equals u plus at to find the acceleration. V in this context is 24, u is 6, a is unknown, but t is also 6. That will be 24 equals 6 plus 6a. Grouping like terms, 24 will still hold. This 6 will move to join it as negative 6 equals 6a. The difference between the two here is 18 and is equal to 6a. Kindly divide both sides by 6 in order to find a, and 18 divided by 6 is 3. So the acceleration here is 3 meters per second square. Friends, this is the end of our journey for looking at problems with Newton's equations of motion. Let's move on to the next lesson that will look at motion graphs, another interesting area to study. Thanks very much. Stay blessed. We'll meet again.